Hi everyone, in this week's lesson we're continuing our electricity topic and we're looking at series and parallel circuits. In a series circuit, all of the components are attached in one large loop. You'll often start with a battery at the bottom and connect this using some wires to a light bulb at the top. In a parallel circuit, however, the different components are connected in a different amount of loops. You can start off with a battery at the bottom and then connect it to a light bulb at the top, but in the middle of this you can have another separate circuit also containing a light bulb. Most houses are set up with parallel circuits running throughout them. This means that you can disconnect one part without affecting the rest of the components throughout the rest of the house. We're now going to look at how charge flows through both a series and parallel circuit.
Similar to the ones that we're going to draw on the whiteboards later. On the left hand side we've got a series circuit, and on the right hand side we've got a parallel circuit. Here we can see we've got two bulbs in each of the circuits. We're going to look at how brightly these shine when we turn the power source on. We can see here in the series circuit that the bulbs aren't as bright, but in the parallel circuit the bulbs are brighter and they share the same brightness. Why do we think this is?
We've just looked at how setting up bulbs in either a series or a parallel circuit can affect their brightness. But what happens to the potential difference and the current? We're now going to take a look at this.
Now we're going to look at a simple series and a simple parallel circuit. To do this we're only going to use a battery and two bulbs for each circuit. So in a series circuit everything is attached in one big loop. So we've got the different components, the battery and the bulb. And like I said before, we're going to use two bulbs here. We're using straight lines to draw our wires using a ruler. And at the top we're going to have our two batteries connected. So our two bulbs connected. There's one, and there is the other. The charge is flowing around the circuit and it's going to light up both of these bulbs. However, what would happen if this circuit was broken? We're now going to look at a parallel circuit. Again, we're going to have a battery at the bottom and we're going to use two bulbs in this circuit that we're going to draw. However, the difference here is that they're not connected in one big loop, but two smaller separate loops. So we're going to have our first bulb here, and our second bulb attached in parallel at the top of the circuit. Now, if we were to break the circuit, the top bulb would stay illuminated, whereas the bottom bulb would go out. In these examples, the battery is going to have a potential difference of 10 volts. So you can put that into both of our diagrams there, that the potential difference of the battery is 10 volts. When components are connected in series, this potential difference is split between the different components, but when they're connected in parallel, the potential difference is the same throughout the circuit. Now, what's going to happen to the current? Like we looked at last week, current is the flow of charge through a circuit. In a series circuit, we're going to say the current is going to be 6 amps, which is the unit that we use to measure it. No matter where you place an ammeter in the circuit, the current is going to read 6 amps in a series circuit. In a parallel circuit, however, the charge is flowing and is split between the different loops found in the parallel circuit. So if the But if the current in this circuit was also 6 amps, here it would be 3 amps, and here it would be 3 amps. This is because the current is split evenly between the different components in the circuit.
Thanks for watching this week's video, everyone. We've looked at series and parallel circuits. Complete your work in the Google form in the Google Classroom for this week. Have a lovely week, everyone.